right, let's look at the organic reactions worksheet question 8. They give us a flow diagram. Very typical exam type question. In the flow diagram below, X, Y, and Z represent 3 different types. 3 different. So all 3 of them are different. Okay? Organic reactions. Remember, we have addition, substitution, and elimination. Those are the 3 we're looking at. Before I even look at the question, I'm going to see if I can identify what those reactions are, because that's going to make my life easier. So we go, I've got an alkane, which is becoming an alkene. I am taking something out in order to get the double bond. This has to be an elimination reaction. Okay? There's absolutely no way around it. My alkene, because it's an alkene, will undergo an addition reaction. Okay? Now, here I've got mild heat, so it's a low heat with a strong base. This makes this a substitution reaction. Now, probably along the way, I'm going to need to identify what P is. So here we've got to be, and we've got a haloalkane. So now we've got to go, okay, what will I end up with? I'm going to end up with an alcohol. Okay, there's absolutely no way alcohol, there we go, I can't spell. There's no way that we can do it any other way. What will happen is this BR is going to go off and it's going to be replaced with an OH. Okay, simple substitution. This OH is going to determine what's going to happen here. All right, so we've looked at it quite nicely. So now they say name the type of reaction represented by X. Oh, wait, we've just done that. We've done it in the first part. So this is an elimination reaction. Okay, so this is elimination. Then they say name 2 conditions for this reaction. Please, guys, learning these conditions is not an option. Okay, it's an elimination reaction. We have to have, and I'm going to write it down, I'm going to do it further down. Okay, so here, this is 8.1.2. We have to have a high heat. You can also say that it's heat under reflux. All right, and we have to have concentrated, strong base. Okay, you can also be specific and tell me either sodium hydroxide or you can tell me potassium hydroxide. But what am I looking for? It's got to be concentrated. Okay? Then, question 8.1.3. Reaction Y represents a substitution reaction, which we knew. Write down the structural formula of compound P. So we look at it and we go, well, I'd said to you earlier already, so we've already made this decision, that bromine's going to come off. Everything else is going to stay the same. Okay, we only want the compound P. That's the organic compound. So, 1, 2, 3 carbons in the longest chain. So, let's go back here. Alrighty, so this is 8.1.3. 3 carbons in the longest chain. 1, 2, 3. Okay, then where the bromine was, we're now going to put the OH. There was a methyl group over here, so we need to put that in. There was another methyl group over here, so we need to put that in. And there we go. All they wanted was the structural formula. They didn't even want us to name it. Great. Nice and easy. Then in 8.1.4, they say apart from the organic reactant, write down the name and formula of the name of the other reactant for Z. So if we go back to Z, so besides the fact that we're going to have the alkene, I have to turn this alkene into an alcohol. The only way I can do that is by adding water. Now they were nice to us in this question. They said name or formula. So H2O or water would be fine. Then they say name the type of reaction represented by Z. Well, we've done that. It's addition. Straightforward. So going through this, the flow diagram, before we even start answering the questions, makes our lives much, much easier when we get to the end. All right? Nice and straightforward. Great. So, here we get another typical question. Hexanoic acid is responsible for the unique odor associated with goats. I didn't know that, but there it is. When it reacts with alcohol X, ethyl hexanoate is formed, which is a fruit flavor. Now, I'm not even going to go anywhere else here. I know I'm going to get ethyl hexanoate. That means the alcohol has to be ethanol. I get it from the ethyl part of the name. Oh, look, I've already answered 8.2.1 because now it says write down the IUPAC name of the alcohol. Okay, well, that was easy enough. That is ethanol. Then they say to you, what is the role of the sulfuric acid in the reaction? It's a catalyst. Okay? Its primary role is a catalyst, but it also can act as a dehydrating agent. Okay? Takes out water as well. Then they say write down, using structural formulae, to write down a balanced equation for the preparation of ethyl hexanoate. Well, they've actually made this easier for us because we know what the acid is, we know what the alcohol is. Let's start with the alcohol. It was ethanol. Ethanol. All right, there's the ethanol. Hexanoic acid, so that's hexy 6. So 1, 2, 3, 4, 5, 6. It's got to be oic acid, so I know I need this. All right. I know, especially for those of you with bigger handwritings, these are a bit of a nightmare because of trying to make sure everything fits. If you need to write it over 2 lines, just make sure it's neat and everyone knows where you're going. So there we go. So now we get ethyl. So here's the ethyl part. There's the O. Here's the hexanoic acid part. So this has got to have 6, okay? 1, 2, 3, 4, 5, 6. And the double bond to the oxygen. And then, of course, we make sure that we have all the hydrogens. Straightforward. And water. Don't forget the water. Okay, please don't forget the water. It's very, 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 very important. Okay. Next question. Give a reason why the test tube and its contents are heated in a water bath and not directly over the flame. Well, alcohols are flammable. Okay, so it is a safety precaution. You can't just say for safety. You've got to tell me why. It's because alcohol are flammable. Alcohols are flammable. Write down one use of esters in the food manufacturing industry. Flavoring. Okay, flavoring, which then gives the smell. Ester questions, very, very important. Okay, nice question. And hopefully you all coped with it.